Okay, adding functions. So I have function f over here is 3x minus 2. Function g over here is negative x plus 5. One way that they can show us to add functions is to say take f of x and add g of x, which means I'm just adding 3x minus 2 to negative x plus 5. So you're literally going to go 3x minus 2 plus negative x plus 5. And a lot of times they'll put parentheses to separate them. But you can imagine that they're not there because all we're going to do is combine like terms. 3x and minus x go together, so 2x. Negative 2 and positive 5 go together, that's positive 3. And here's the answer. Now the thing that's a little screwy about operations with functions is different textbooks, different teachers, different professors you're going to have in college are going to use different notation. So they can have f of x like this plus g of x, or they could do parentheses with f plus g and parentheses with x like this, or they could just say find f plus g. And all of it means to add this one and this one together, combine like terms. So I want you guys to have some knowledge of what these are going to look like. This is the notation that's used on the assignment I'm going to give you later, and we'll practice with that. This is what's used in textbooks a lot because it uses the least amount of ink. But it all means the same thing. If you're seeing adding f and g together, there's a plus between the f and the g, you're going to add them together. All right, so adding's not that bad. You just combine like terms. Subtracting has a little bit of a twist, but it's not that bad. So if we go to subtracting, here's f and g, the same exact functions. It says f minus g. That means I'm going to have 3x minus 2 minus negative x plus 5. And here's where the parentheses come in handy, really just for the second one. Because I'm subtracting both of these, you really have to distribute that and think of it as being plus x minus 5. And then this part would just stay the same. So you have to subtract both of the terms on the second function. And then you combine like terms like normal. So 3x and x go together to make 4x. Negative 2, negative 5, or minus 2, minus 5, however you want to say that, goes together and makes minus 7. And you want to pay attention with subtraction because the order is going to matter. If they suddenly say g of x minus f of x, then you'd have negative x plus 5 minus 3x minus 2, and this is the one where the signs are going to change. So I would still have negative x plus 5, but I would distribute the minus sign to these, which makes it negative 3x and positive 2. And essentially what this is going to do when we combine like terms is change the signs on your answer. You'll have negative x and negative 3x that make negative 4x. Positive 5 and positive 2 make positive 7. So you just want to be careful with subtraction that you're distributing to the second one, whichever one's being subtracted, and that you're doing it in the correct order. So mostly it's combining like terms with adding and subtracting, but on the subtracting you've got to distribute the subtraction to everything that's in that function. If it's got 1 term, 2 terms, 3 terms, 4 terms, they can be big. And then combine like terms. Different ways to write subtraction looks the same as addition. I could put f minus g in parentheses and x in parentheses, or I could just say f minus g. Those are saying the same thing as saying f of x minus g of x. These are a little shorter, so textbooks, companies, and people who write standardized tests tend to use these because they're shorter. Okay? All right. So where we're going to spend a little bit more time is multiplying and dividing functions. So we're going to go down through the basics of multiplying and dividing, and then we're going to talk about details, because multiplying especially could be simple or difficult depending on what you're multiplying. All right, so if we come down here to multiplying functions, we're going to use the little times dot. And it says that multiply f times g. That means I'm taking x squared times 3x minus 2. If you have a binomial, trinomial, anything more than one term, you're going to put it in parentheses. And that means when I'm multiplying, I get to distribute this to both of those, and then I'll be done. So mostly this is just like operations with polynomials. It's just that we have function notation. So x squared times 3x is 3x cubed. X squared times minus 2 is minus 2x squared. So that one's not too bad because it was just distribution. Now, different ways to write multiplication. There are a lot of ways to write multiplication. They could write f of x, I just wrote f of g, sorry, f of x times g of x. That one's not used very often. They can put in parentheses just fg with x. They can just say fg because they assume if you see two variables without anything in the middle that you know that means times. Or they could do the same things with the times dot. They could put f times g like this. So depending on who teaches your next math class where you see this, any of those would be possible to show up. So I just feel responsible for showing you all of that. I did not see all of those different ways to write it in high school, and I was very confused in college math. So I'm making sure you guys have a chance to see that there's more than one way to write the notation. Okay, so we're going to briefly talk about division, and then we're going to do a bunch of examples of different things. Okay? So, here's a function f and a function g. It says f divided by g. You're going to like this a little bit. Yeah. So, we're going to use fractions. 9x squared over 3x to the 6th. Sometimes you just make the fraction. Sometimes we have to reduce the fraction. This one reduces. 9 divided by 3. I could take these, divide by 3, make it 3 and 1. So I'd get 3 on the top. And then we have to think about our exponent rules. If I have x squared on the top and x to the 6th on the bottom, you can kind of think of it as battling it out on two sides. So there's 6 of them down here, 2 of them up here. These 2 cancel 2 of them down there. And you'd be left with x to the 4th in the denominator. We also learned that you could take 2 minus 6, which gives you negative 4. And a negative exponent puts it in the denominator. So either of those methods work. And you can put the 1 down there if it makes you feel better. But since there's an x to the 4th down there, we don't necessarily have to. And then if it says g divided by f, that means we would just flip it over. Which means instead of 3 over 9, I'd have 1 over 3. So the 3 is going to go on the bottom. And then the x to 4th would go to the top because 6 minus 2 is 4, and that would stay in the top. So you just want to be careful about the order in which they tell you to divide. This is sort of an archaic way to write division. They're usually going to use a fraction bar. They might say f of x over g of x like this. They might say f over g in parentheses with x in parentheses. They might just say f over g. They could say f divided by g with the old-fashioned division symbol. Any of these mean the same thing as what we're doing up here at the top. So lots of different ways to write the same thing. That basically just happens because there's nobody telling mathematicians they all have to use the same notation. It's kind of a pain in the butt. The further along you get in math, the more that happens, and everybody makes up their own notations so they can look different than everybody else and write a textbook to make money. All right, we're halfway done. Let's go to the next page. So, most of these are not going to take that long. We're going to go through just a mixture with the same functions. So my f function is 12x squared. My g function is 36x squared. My input variable is x for both of those. So if it says f plus g, that just means I'm going to take 12x squared and add 36x squared. Since they both have x squared, that means they're like terms. I can add 12 and 36 together and get 48x squared. So all we did was a little bit of addition because we were